Hello everyone, my name is Chidowere Jombuya, presenter. Um, in today's class, we are going to look at power losses in a power system. And that will lead us to understand what are the losses which we normally encounter in our power systems and in our electrical equipment. We are going to start by defining what power losses are. So, power losses are those losses that occur in our power systems and electrical equipment when electrical energy is generated, when electrical energy is transmitted, when electrical energy is distributed and utilized. That is when we say there is or there are power losses in a power system. And if we don't want to put it that way, we can still say that power losses in a power system, that it is the difference between power delivered or power supplied and power consumed or utilized. Now, let me explain. We can use it and formulate a mathematical expression. We can now say power losses or power loss in a power system or in an electrical network or in electrical equipment is given as P. P loss is equal to Pi supplied minus Pi consumed stroke utilized. So when power is supplied, then utilized, that means the difference between the power supply and power consumed gives us what we call the power loss, where P loss is equal to power lost in the system. Then Pi supplied is equal to power delivered. Power delivered to the system. Then we have P consumed equal to power that is utilized by loads. So this is how the formation goes. And remember that these power losses, they had or they affect the general running of the power system in such a way that the operating costs to maintain the generators, the equipments, all these things now will go high because of these various losses. And another effect is that when these losses occur, the efficiency of the system, the efficiency of the network will not be the same again. So they reduce, or these losses reduces the efficiency of that very particular system. Now, these losses could be in megawatts, it could be in kilowatt. Of course, we have kilowatts this way, then we have megawatt. Here is equal to 10 raised power 3. Then here is equal to 10 raised power 6 watt. So now, another thing we are going to look at now will be the classification of these very particular power losses. Power losses can be classified into two divisions or into two categories. We have one, the technical losses. technical losses, and II, non-technical losses. So these are the two losses we have in a power system: technical losses and non-technical losses. We are now going to consider again the losses that fall under this very particular technical losses, and equally we are going to look at the definition of technical losses and know why we have it. Now we have one now on technical losses now. On technical losses. Now, what are technical losses, or what is a technical loss? Technical losses are those losses that occur in our network due to electrical properties or characteristics of the equipment. And these losses are more or less not of man making, but as a result of the equipments which we are using to generate, transmit, distribute. Probably any physical property of it that resulted within the process of operation will be termed as a technical loss. And we have under these technical losses, now we have one transmission line loss. Then two, we have the transformer loss. Three, we have corona loss. Four, we have dielectric loss. Five, we have copper loss, which is given as I squared R loss. So these are the various losses that falls under technical losses. We have the transmission line loss, transformer loss, corona loss, dielectric loss, copper I square R loss. Then we are going to explain one after the other. Then let's take on transmission line loss. When do we say we have transmission line loss? When the resistance of a transmission line increases. When it increases, what is the effect? The current increases, and there will be a very maximum loss, which comes in the form of heat energy. Now, transformer loss now. Under transformer loss, these are losses that occur in the transformer environment. And inside this transformer now, we have something like the core loss, or what we call iron loss. Then inside the transformer again, we have what we call the copper loss, or still I squared R loss. Now on this core loss, we have under this core loss now, we now have something like under core loss now, we have hysteresis loss. Then we only have under this core eddy current loss. So have eddy current loss under core loss in the transformer. And what is hysteresis loss? Hysteresis loss is a loss that takes place in the core of a transformer as a result of magnetization and demagnetization of the core. So this gives us hysteresis loss. Then eddy current is as a result of cycling, alternating current in the core of the transformer. And then copper loss is a loss as a result of the transformer windings. Now, we will now go to corona loss. Where do we see corona, or where does corona normally occur? So corona occurs on a high voltage transmission line. It occurs on a high voltage transmission line as a result of electric field surrounding the conductor, or the movement of electrons on that line. When it ionizes the surrounding air, we say that corona has taken effect. Now, let me explain, let me demonstrate. Let's say these are our conductors. These are conductors. Now, at this point here, A, now electric field is built here, it piles and go up high. So there will be a point we call ionization point. It's the surrounding air around this conductor now. It will break down the air particle or the dielectric strength of the air particle. As soon as the air particle, the electric strength is broken down, that means corona is said to take place. And it normally takes place on high voltage lines above 33 kV, probably from 132 kV, 330 kV, etc. and etc. So this is where corona occurs. And there are three effects of corona. One is hissing sounds. Hissing sound. Two is heat energy. And three, we have a yellow or a faint violet glow. So around here now, you see a faint violet glow like light. Like light. Then there is a hissing sound or a hissing noise which you normally hear under that high voltage transmission line. Then there is heat energy that equally escape a form of heat. Now we go to dielectric loss. Now dielectric loss is a loss that happens on insulating materials. On insulating materials as a result of the electric field that is connected to them. Example is mica. We have a mica. It's a dielectric material or substance. Then we have plastic. Then we have rubber. We have air. All these things are various dielectric materials. So we say they are insulating materials. There are loss that occurs in insulating materials when the electric field energize their movement. Now we have copper loss. This copper loss is the normal loss that occur in our conductors, and we have it like Pi loss is equal to I squared R, where P loss is equal to power lost in the system. Power lost in the system. Then we have I as current, or call it line current, current stroke line current. Then R is equal to the resistance of the line. So this is where we draw the curtain close on power losses in a power system. In our next class, we are going to vividly define the non-technical losses. We are done with the technical losses and their various examples. Next class, we'll look at non-technical losses, their examples, their effects, and other things that follows it. Thank you and God bless you. Remember, follow me on my page, Chidore Jumbo. Thank you and God bless.